Okay, so this is a continuation of our examples for plane areas in polar coordinates. So our third example is to determine the area so that lies inside r is equals to 3 plus 2 sine theta and outside r is equals to 2. So based from the format of the polar curves, so the first curve, it has a ratio of 3 all over 2, so which is 1.5. So that makes it looks, or that would be a curve for a limacon. And then r is equals to 2, so that is a circle. Okay, so we are to determine the area, so that lies inside the limacon, but then it should be outside the circle. Okay, so inside the limacon, but then outside the circle. So we need to take a look at the boundary of the limacon and that of the circle. So we have r is equals to 3 plus 2 sine theta for the limacon and r is equals to 2 for the circle. So let's try to graph this one. So again, as I mentioned, so we can use this formula. So in finding the values of r for different values of theta. So we can start from 0 degrees up to 360 degrees, so as to properly graph, okay, so the given polar curve. However, I'm not going to show the table anymore, but we'll do the uh, we'll do the graphing so right away. So using uh, this tool, so limacon, so that is r is equals to 3 plus 2 sine theta. Okay, so for r is equals to 3 plus 2 sine theta, so we'll start with 0 degree. So anything that is to the right side, so that way makes it positive. Anything to the right side or the polar axis, so that will always be the positive. Okay, so opposite the polar axis, so that would be the negative part. So let's say in this case, so I'll start with 0. Okay, so 0 degree. Mm, so this is considered a 0 degree. So this would be considered a 0 degree. And then we have, so since it's divided by 3, so I'll have 30 degrees, then we have 60 degrees, then we have the 90. Of course, this would be 180, then we have the 270. So we could have 90, 120, 150 if we want. And so on. So 180, so we could have 210 here, 240, 270, 300, and then we have the 330, and going back, so that would be the 60 degrees. So as you can see here, so for the limacon, so we have our polar curve, so to be r is equals to 3 plus 2 sine theta. Okay. So when theta is 0 degree, so sine 0 is 0. So that makes r equal to 3 only. So that's why we have, okay, so at 0 degrees, so that makes it 3. However, at sine 30 degrees, 30 degrees would be 1 half, so times 2, so that would be 1. So making it 3 plus 1 to be 4. So as you can see at the 30 degrees point, so that makes it 4. And then at 90 degrees, so sine 90 degrees is 1, so times 2, that would makes it 2, so plus 3, that makes it 5. So that is why at 90 degrees, so it's 5. And if we continue, okay, so at 180 degrees, so sine 180 degrees, that will be 0. Okay, so that will be 0, and then 3 plus 0, that is 3. Actually, it's not negative 3, it's 3. So as long as it points towards the angular position of 180 degrees, then that makes it positive. So the left hand side for 180 degrees is the positive, and then the right hand side from the pole, okay, or from the origin, so that makes it the negative. But in this case, so since we're talking about 180 degrees, the angular position, then that makes it a positive 3 at the left side. And then if we continue until the 360 degrees, so it will form a limacon. And then the next one is we have, so this is the uh, 3 plus 2 sine theta. And then we'll have this one, so that is the r is equals to 2. So r is equals to 2, that means it's always 2. The radius is always 2. So from the pole, okay, and then that will be in 360 degrees. So I'll start with 0 degree. So you can see here. So regardless, so whatever would be the position, so it's always 2. Okay, so it's always 2 from the pole. So so we have the graph of the limacon as well as the circle r is equals to 2. Okay, so that's how we graph it. So next is let's continue with this one. So I'm going to add, okay, so our graph, and this is how it looks like. So it says here that we are going to determine the area that lies inside, okay, so something that lies inside the limacon. So this is inside the limacon. So this is the entire limacon. However, we have a limiting condition here that it should be outside the circle. So it is inside the limacon, but then outside the circle. So this is the circle. The circle is the green one, and then the limacon is the red one. So it should be inside the limacon, but outside that of the circle. So this is outside. So therefore, the area that we are concerned here is, so this is the area, okay, so inside the limacon, but then outside the circle. So the area that we will be finding would be this yellow area. So this is the area, okay, so inside the limacon and outside the circle. So we are to find that. Okay, so to find that area, so actually, so we need the point of intersection. So as you can see here, so these are the 2 points of intersection. Okay, so one is at the third quadrant, the other one is at the fourth quadrant. So there are 2 points of intersection. And we'll try to find that point of intersection. So to find the point of intersection, so we use our two polar equation. So one is r is equals to 3 plus 2 sine theta, and the other one is r is equals to 2. So since both are r, so we can equate the two. So that will make it, so 3 plus 2 sine theta is equals to 2. And then we transpose uh, 3, so 2 minus 3, that would make it negative 1. So therefore, so 2 sine theta is equals to negative 1. Then sine theta then, so will be equivalent to negative 1 half. So what is theta then? So theta would be inverse sine of negative 1 half. So we can use our calculator in solving for that. Okay, so let me use one. So inverse sine of of negative 1/2. And then that is equivalent to negative 30 degrees. Okay, so it says that theta is negative 30 degrees. And plotting the negative 30 degrees, it appears that the one that we got is actually this one. So this is the negative 30 degrees. So the point of intersection at the fourth quadrant. Okay, so remember, so this is the 0 degree. So this is 90. So this is 180. And this is 270. Or this is pi over 2. This is pi. This is 3 pi all over 2. And this is uh, 2 pi or 0. Okay. Negative 30 degrees. So if we want it in terms of a positive angle, so that would just be 360 minus 30. So negative 30, that's the same as 330 degrees positive. Okay. So to convert that into radian, so we just multiply it with pi all over 180. So negative 30 over pi over 180, so that would give us to have a negative pi all over 6. Okay. So negative 30 so times pi all over 180. Okay, so the lowest term would be, so we could divide, okay, by 30. So 180 divides 30, that is 6. So that makes it negative pi all over 6. So similarly, so the 330 uh, times pi over 180, so that makes it 11 pi, 330 over 180. So that makes it 11 over 6. Okay? So 11 pi all over 6. So it's either we're going to use 330 or 11 pi all over 6. So 1 is negative 30 degrees. Okay. So next is, how do we get the angle at the third quadrant? So remember this axe. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So it tells us here, so where the trigo function is positive. So first quadrant, all of the trigo functions are positive. Second, sine is positive. Third, tangent is positive. Cosine is positive at the fourth quadrant. But then, as we can see here, so we're talking about sine function, but then we have a negative value. Okay, so a negative 1/2. And as we can see here, that uh, sine is positive at the first and second quadrant. Okay, so sine, so for sine, so it is positive at the first and second quadrant. It's negative at the second or third and fourth quadrant. As we can see here, so the one that we got is the fourth quadrant. Okay, so which is a negative 30. But then, so how do we get the third quadrant? So again, so the formula that we will be using, so for first quadrant, so it's just actually the theta, and then for second quadrant, so we subtract uh, theta from 180 degrees, and then for third quadrant, we add 180 degrees plus theta, and then for fourth quadrant, that is 360 degrees minus theta. In this case, so we don't consider the sine, so it's 30 degrees. So that is why at the fourth quadrant, that would be 360 minus 30. That makes it 330 degrees. So if we want a positive angle. So if we want a negative angle, so it's just negative 30 degrees. And then for the third quadrant, so in here, so we can now get, so theta 1 is negative 30 degrees, or that is this equivalent to negative pi all over 6. So we can make it positive as well as 330 degrees or 11 pi all over 6. For the second angle, so which is at the third quadrant, so we'll be using this formula. This 180 plus theta. So that makes it 180 degrees. Our theta is 30 degrees, so that makes it 210 degrees. So 210 degrees over 180, so that makes it 7 pi all over 6, or 7 pi all over 6. Okay, so those are the points of intersection then. So this one is 210 degrees or 7 pi all over 6. So now that we know the points of intersection, so we can now find, okay, so we can now find the area. Okay, so we can now find the area. So actually, in finding the area, so those points of intersections are critical. Okay, so since that will tell us, so what area are we going to get? Okay, so in this case, if I am going to use the boundary, let's say from 0 to 360 degrees, so I'll be able to get the entire area. Okay? So I'll be able to get the entire area. However, so since it's just the yellow area that we are going to find, so how do we get that? So to get that is, I'm going to start with the area involving the limacon first. So how are we going to do that? Okay. So let's say I'm going to get the area for, I'm not going to evaluate the area entirely from 0 to 360. What I'm going to get will be, I'm just going to get this one. So from negative 30 degrees, okay, so from negative 30 degrees, I'm going to get that area until, from negative 30 until 210 degrees. So therefore, this is just the area that I'll be getting. Okay, so this will be the area that I will be getting if I am going to get the yellow area. However, the blue area this time, okay, so involving the limacon, so from negative 30 degrees to 210 degrees, is in excess. I need to remove something. So what will I remove? Okay, so I can remove the area covered by the circle. So in this case, I'll start again from negative 30 degrees up to 210 degrees. From negative 30 to 210 degrees. So similarly, so in short, in getting the area or the total area, so I'm just going to get the area of the limacon minus the area of the circle. But then our boundary is from negative pi all over 6 up to 210 degrees, or that is 7 pi all over 6. Okay. Sir, why did I not use the positive 330 degrees? Kasi the positive 330 degrees, so that is greater than the 210. So usually, the lower limit should have a lower value as compared to the upper limit. So to ensure that the area that we will be getting will be positive. Okay? So kaya instead of 330 degrees ang gagamitin natin, so we're going to use the negative 30. Kasi we'll start from negative 30 until 210 degrees. Okay? So that is on how to get the area. Okay, so in the end, so this is the area of our concern only. So we can get that area, so by subtracting the area of the limacon from negative 30 degrees to positive 210 degrees, and then subtract the area of the circle from negative 30 degrees to positive 210 degrees. And as we can see there, so we have the same limit. So again, our formula for the area, so area is from the lower boundary alpha to upper boundary beta, and then 1/2 r squared d theta. Okay, so the area, we'll start with the area of the limacon. So the area of the limacon is from negative 30 degrees, or that's the same as negative pi all over 6, until 7 pi all over 6. And then the area of the limacon, that is 1/2. So our limacon, so this one is the r is equals to 2 plus, or 3 plus 2 sine theta. R is equals to 3 plus 2 sine theta. So that would just be 3 plus 2 sine theta, and then square it, d theta. Then minus the area of the circle from the same, negative pi all over 6 to 7 pi all over 6. And then I have 1/2 our r. So r for the circle is r is equals to 2. That would be 2 squared d theta. So that makes it the total area then, so to be the integral of negative pi over 6 to 7 pi all over 6. So I'll have 1/2, and then so expand this, so that is 9 plus 2 times 3 times 2, so 4, 12, so that will be 12 sine theta, and then plus 2 sine theta squared will be 4 sine squared theta d theta. And minus from negative pi all over 6 to 7 pi all over 6. So 2 squares 4 divides 2, that is 2. So that will just be 2 d theta. So since the boundary are just the same, so we can algebraically add, or subtract. Okay. So we have this one, so we distribute 1/2. So that will become 9 all over 2. But then we have minus 2 here, because they are exactly the same. So we can perform right away the operation. So 1/2, so that would make it the same as 9 all over 2 minus 2. So which is, so 2, 9, then 2 times 2 would be 4. So that making it 5 all over 2. Or in short, that would be from negative pi all over 6 to 7 pi all over 6. And then I distributed it. So that would be 5 all over 2. And plus 1/2 times 12, that is 6 sine theta. And then 4 times 1/2, that would be plus 2 sine squared theta. And then everything will be multiplied by d theta. Okay, so we combined the two. So since we are of the same limits, but if they are not the same limits, we're not going to combine. Okay. And next is, so I can integrate 5 over 2 and 6 sine theta, but not 2 sine squared theta. So remember that sine squared theta, it's the same as 1 minus cosine 2 theta, or 1/2, minus cosine 2 theta 1/2. Or just simply, you can combine the two. So 1 minus cosine 2 theta over 2. So we substitute. So negative pi all over 6 to 7 pi all over 6. So 5 over 2 plus 6 sine theta. Then plus 2. So multiplied it with 1 minus cosine 2 theta all over 2. And then d theta. So 2 and 2 would be cancelled out, so leaving us to have 1 only. So that makes it the total area from negative pi negative pi all over 6 to 7 pi all over 6. So 5 over 2 plus, let's have 5 over 2 plus 1. So that would be 5 plus 2. So giving us a 7 over 2. So this would be our simplified formula. 7 over 2 plus 6 sine theta and minus cosine 2 theta d theta. So sine theta can be integrated right away. So cosine 2 theta, we have a u of 2 theta. So du will be 2 d theta. So therefore, we'll have a neutralizing factor of 1/2. So our answer then, so for the total area, so we can now integrate. So integral of 7 over 2, that will be 7 over 2 theta. And then integral of sine will be negative cosine. So negative 6 cosine theta. And then integral of cosine is positive sine. But then we have a negative for the cosine there. So negative neutralizing factor of 1/2. So negative 1/2. So sine 2 theta. And then that will be evaluated from negative pi all over 6 to 7 pi all over 6. Okay, so we substitute then the upper boundary, which is 7 pi all over 6. So 7 over 2 times 7 pi all over 6 minus 6 cosine, so 7 pi all over 6, and minus 1/2 sine. So 2 times 7 pi all over 6, that will become, so 2 over 6 is 1/3. So that makes it 7 pi all over 3. Then minus the lower boundary, so 7 over 2, so pi is negative pi all over 6. And then minus 6 cosine, so negative pi all over 6, minus 1/2 sine. Okay, so we'll have 2 times negative pi all over 6. So 2 over 6 is still 1/3. So I'll have negative pi all over 3. And then we simplify. So 7 times 7 is 49. So 49 pi all over 6 times 2, or 2 times 6, it's 12. And then, so we can use our calculator. So negative cosine 7 pi all over 6. Okay, so do I have a calculator here? There's my calculator. Okay, this one. So it says that we should have negative 6 cosine 7 pi all over 6. Negative 6. Okay. So I should make it in radian mode. So it's negative 6, then cosine 7 pi all over 6. So 7 pi. 7 pi and then over 6. I can make it in fraction. Okay. So the answer is 3 squared of 3. Okay, so 3 squared of 3. So negative 6 cosine is positive 3 squared of 3. Then I'll have the negative 1/2 sine 7 pi all over 3. So negative 1/2. So it's negative 1/2 sine. Okay, so shift pi all over 3. Okay. So negative 1/2 sine pi all over 3 is negative square root of 3 all over 4. So negative square root of 3 all over 4. And minus, I'll have a negative, okay, so 7 pi all over 12. So negative 7 pi all over 12. And then we'll have the negative cosine of negative pi all over 6. Negative 6, negative 6 cosine of negative pi all over 6. So the answer will be negative 3 square root of 3. So negative 3 square root of 3. So minus 3 square root of 3. And then lastly, we'll have negative 1 half. So sine negative pi all over 3. Negative 1 half. So sine negative pi over 3. So the answer is positive square root of 3 over 4. Positive square root of 3 all over 4. And thus, so combining, so I'll combine these two. So this one, so distributes it, that makes it positive. Okay, so 49 plus 7, that is 56 all over 12. So 56 pi all over 12. And then negative and negative, so that is positive 3. So 3 square root of 3 plus 3 square root of 3. So that uh, gives us a 6 square root of 3. Okay, so plus 6 square root of 3. And then the negative square root of 3 over 4. Then distribute it. So negative square root of 3 all over 4. So that makes it, so it appears I'll have negative 1/4 minus 1/4. That's negative 1 half. Or that is negative square root of 3 all over 4. And then I can simplify. So what's the simplified version of 56 over 12? So 56 over 12. So we'll have 14 over 3. So which is 14 over 3 pi. And then plus, okay, so I can combine this one. That would be 4. So 24 square root of 3 minus square root of 3. Correct for that one. So 3 square root of 3. So which makes it 14 over 3 pi plus 23 square root of 3 all over 4. And let's try to double check. I think there's something wrong. So the answer will be, so 3 square root of 3, negative, negative, so that would become positive. Okay, so the answer there will, but this is like 14 over 3 pi. What is 14 over 3 pi? 14 pi all over 3, and decimal is 14, and plus 23 square root of 3 over, okay, so it's around 24.62. Okay, so I'm just making sure I arrived to correct answer. So let me just verify it. What's wrong? Oh, I see. So this should be at square root of 4. Uh, it should be square, or it should be 2. Okay, so square root of 3 all over 2. Okay, so that what makes it wrong. So this should be 2, and then this would be 12, and 12 minus 1, that will be 11 over 3, or which is the same as 24.187 square units. Okay, so I mess up with 1/4. Okay, so I mentioned 1/4 plus 1/4 is 1/2. However, I had written 1/4 still. Okay, so that is on how to determine the area. So that lies inside 3 plus 2 sine theta, but then outside r is equals to 2. So let's have another one. It's the same example, but it talks about a different area. Okay, so that's why I'm going to use the same graph, but then from here, it says to determine the area outside the limacon, okay, and inside r is equals to 2. So inside the circle, but outside the limacon. So since the limacon is the red one, so obviously, so something that is outside is anything outside that of the limacon. But then, so there's an area which is a part of the circle. So which is this area. So this is the area that we will be finding. So this time, so if we're going to find that, so we're going to use the limit. So this time that will be the, they call that one, that is 7 pi all over 6. So this is 7 pi all over 6. And then, so since the area that involves here is the area below, so meaning the area that I'm going to evaluate this from 7 pi all over 6 or 210 to, so this until here. So our lower limit would be 7 pi all over 6, and then our upper limit will be 11 pi all over 6. This is 11 pi all over 6. So it is the positive angle that we're going to find. So since our area will, or the boundary, so we'll start from the lower value of 7 pi all over 6 until the upper value of 11 pi all over 6. Okay. So on how to get the area, so it's the same thing. But this time, so once we get the area of the, in here, the area from 7, the area of the circle, okay, so the area of the circle is bigger this time. So this is the area of the circle. Okay. So this is the area of the circle. So that's why I'll start with the area of the circle. So the total area would be the area of the circle. And then I'm going to subtract the, what am I going to subtract? I'm going to subtract the area of that of the Limacon. Because for the Limacon, so this is just the area that we will be getting once we evaluate the Limacon from 7 pi over 6 to 11 pi all over 6. Okay? So our total area then, so would be the area of the circle, so minus the area of the Limacon. And we follow the same formula. So area, or the total area then, so would be the area of the circle, so that is from 7 pi all over 6 to 11 pi all over 6. And then that is evaluated, so the area of the circle is 1/2 r squared. So our r is 4 square. And then minus the area of the Limacon, again, so from 7 pi all over 6 to 11 pi all over 6, then 1/2, that is 3 plus 2 sine theta squared. So d theta and d theta there. So the total area then, so will be, actually it's the same thing, no? So 7 pi all over 6, so it just becomes negative. So this would be 2 d theta, and minus from 7 pi over 6 to 11 pi all over 6. So 3 square, that will be 9 over 2, that is 9 all over 2. And then, so 2 times 3 is 6, times 2 is 12, then divide it with 2, that makes it 6. So plus 6 sine theta. And lastly, so we'll have 2 sine squared, so that would be 4 sine squared divided with 2, I'll have 2 sine squared theta d theta. Then combining, I'll just combine. So from 7 pi over 6 to 11 pi all over 6. So 2 minus 9 all over 2, that is the same as 4 minus 9. So which is negative 5 over 2, then plus 6 sine theta. And then the same as what I did before. So 2 sine squared theta. So sine squared theta is 1. Okay. So this is the same as 1 plus cosine 2 theta all over 2. So 2 would just be cancelled out. So just leaving me to have 1 plus, or sorry, so it should be negative. Everything should be negative. So this is negative and negative 1 Okay, so negative, negative 6, negative 1, the negative cosine 2 theta, d theta. So finally, our total area then will be from 7 pi all over 6 to 11 pi all over 6. We'll have negative 5 over 2 minus 1, that will be negative 7 over 2. Minus 6 sine theta minus cosine 2 theta, d theta. Okay, so this time everything is in negative. Yung kanina, yung dulo lang yung negative. No? Oh, sorry. Sine theta is negative. So this should be 1 minus. So therefore, this will be. Okay, so this is plus, but then this one will become plus cosine 2 theta. So nag-alternate sign lang sila. No? So this one is positive, positive, negative. So this time around, it's negative, negative, positive. Okay, so we integrate then. So we'll have negative 7 over 2 theta. And then integral of sine is negative cosine. And then we have negative 6. So that makes it positive 6 cosine theta. And then cosine, integral of cosine is positive sine. So which is sine 2 theta. But then neutralizing factor of 1/2. Evaluate it from 7 pi all over 6 to 11 pi all over 6. And for our total area, so we'll have negative 7 over 2 times 11 pi all over 6, then plus 6 cosine, so 11 pi all over 6, plus 1/2 sine, so 2 theta, so 2 over 6, that will be 3. So that would make it 11 pi all over 3. And minus, so negative 7 over 2, so we have 7 pi all over 6 plus 6 cosine, so 7 pi all over 6 and plus 1/2 sine. So 2 theta, so that will be 7 pi all over 3. So we'll have then negative 7 times 11 is negative 77 pi all over 12. And then plus 6 cosine 11 pi all over 6. So 6 cosine 11 pi all over 6. So which should be in fraction. So 3 square root of 3. So we have 3 square root of 3. Then 1/2 sine 11 pi all over 3. So 1/2 sine 11 pi all over 3. So negative square root of 3 all over 4. So minus square root of 3 all over 4. And minus negative 49 all over 12 pi. Then 6 cosine 7 pi all over 6. 6 cosine 11 pi all over 6. So we have 3 square root of 3 plus 3 square root of 3. And then 1/2 sine 7 over 3. 1/2 sine 7 pi over 3. So square root of 3 all over 4. Plus square root of 3 all over 4. So total area, so distribute, this one became or will become positive. So we'll have 28. Okay, so negative 77 uh, plus 49. So 27 plus 1, so 28. So negative 28 pi all over 12. And so negative and negative. Okay, so let me check. There's something wrong with 6 cosine 11 pi all over 6. 6 cosine 11 pi over 6. So it's positive. 6 cosine 11 pi all over 6. How about 6 cosine 7 pi all over 6? 6 cosine 7 pi over 6. Okay, so this should be negative. Negative 3 square root of 3. Okay. Kasi pag dinistribute natin yan, so negative and negative, that would make it positive. So that would make it 6 square root of 3. Then negative, then this one will become negative as well. So that makes it negative square root of 3 all over 2. So 28 all over 12. So it's 7 over 3. Negative 7 pi all over 3. And then this one, it's the same 11 square root of 3 all over 2. So which makes the total area, so negative 7 pi all over 3. So negative 7 pi all over 3. Then plus 11 square root of 3 square root of 3. Mm, 12, sorry, 11 over 2. Ayun. So 2.196. So it's 2.196 square units. And that's it. Good day.